So before we all go off to coffee and everybody's obviously happy we go there soon, I guess. I'm Meiert Grootes. I'm currently a postdoc at the Mathematical Institute for Nuclear Physics, just down the hill. We also do astronomy and astrophysics. And I'd like to take the opportunity to say a few brief words about the poster I've got right outside here, where we've been using the Galaxy and Mass Assembly Survey to look at the questions of interest to this conference from a slightly different approach. So what we're actually asking is, obviously in some form gas must come into galaxies, and how does this process, which is quenched potentially by environment, depend on the environment? So kind of from the other side, can we say something about the actual process of fueling? The standard paradigm is obviously that when a galaxy becomes a satellite, then all fueling is cut off. And we've also heard about the central galaxies where AGN feedback can control the further accretion of gas, cutting that off. But these processes are not thought to affect other satellite galaxies in a group environment. So what I've been doing is taking a volume-limited sample of morphologically selected spiral galaxies and using a group catalog, going down the halo mass function to very low mass groups, where the masses can be determined using velocity dispersions, and then using these spiral galaxies as test particles, linking their star formation rates to their ongoing supply of gas, and looking at how that and how their specific star formation rate stellar mass relation, shown here, with the specific star formation rate and the stellar mass, depends on environment. And what one generally finds is that there is almost no discernible difference between satellite group spiral galaxies and their field counterparts at a given stellar mass. And the only point where this breaks seems to be in groups with dynamical masses of above 10 to the 13.6 solar masses roughly, and there only if there's actually an AGN seen in the group. So these AGN are not located in the galaxies shown on this plot, but they are in another group member galaxy, predominantly found to be the group's central galaxy. So this basically gives us an empirical reference saying there is star formation going on in these spirals. Star formation is at the level of the field. The gas fueling seems to be at the level of the field, because if you look at the offset of, at the distribution of the offset of the specific star formation rates for these galaxies from the field relation, you see a peak with specific star formation rates at the level of the field, and you see a strongly suppressed second population. And the relative heights of these populations varies with whether or not there's an AGN present. So what we're getting here is the possibility that there is actually ongoing gas fueling in the group environment, rather than a total quenching, and that there actually may be some indication of an AGN feedback mechanism operating through the IGM of the group, but that's obviously tentative, and I'd be happy to discuss this with anybody who's interested. Thank you.
So, yeah,